In this particular video, we are going to discuss chapter-wise IB physics, and the first topic is measurements and uncertainties. Measurements and uncertainties. So here in this particular topic of measurements and uncertainties, we are going to discuss about the scientific way of investigation, scientific way of study. So physics is a branch of science. What do you mean by physics? Physics is a branch of science that deals with the study of matter and the principles governing its behavior. Study of matter and the principles governing its behavior. So when I said study of matter, it includes all the microscopic and microscopic and macroscopic objects, and the principles governing its behavior. The principles governing its behavior, when I said principles, the laws, okay, that governs the behavior, governs the behavior of these objects. So as we said, physics is a branch of science. Every science actually is studied using the scientific way of investigation. So what is that scientific way? Scientific way of study or investigation. Scientific way of study or investigation. When we say scientific way of study or investigation, you have to follow the scientific steps for studying any particular event. So what are the scientific steps? So the first comes is the observation. So continuous observation of an event. Okay. And then identify what are the variables, what are the physical quantities actually that is going to affect this phenomenon, or that is going to affect the event. So we have the physical quantities. So what are the physical quantities actually involved in this? So you need to identify those physical quantities. And then what you need to do is you need to identify the physical quantities variables, and then see what is your dependent variable, what is your independent variable, what are the control variables, okay, and the parameters that is going to affect in this, in that to that particular event. So what are the assumptions that is taken for the investigation or during the observations? What are the mathematical assumptions or constants considered during the investigation or observations? So that is it. Then after this, identifying these variables and the factors that is affecting, then we need to focus on the data that is collected. So we call it the raw data or the data that is obtained for the physical quantities. Okay, so once you got the raw data, you need to analyze these data that we got, analyze the data, find out the correlation between variables, finding out quantitative, the correlationships between two variables, what are the control variables. So quantitatively analyzing this, right? That is analysis. Okay, so analyzing the raw data analysis, and then we can evaluate our analysis where things are going correct, where things are going wrong, or what is the like we considered the uncertainties, the errors that is associated with the data, right? And the mathematical interpretation of the analysis, everything that is included here in the evaluate. And after the evaluation, we can only conclude the correlationship between the variables or something, some concrete evidence related to the uh, phenomenon or related to the event. So this is what is the process of investigation, or the scientific approach to study something. So physics is also a branch of science, and it deals with, as I said, different matters and the principles, like laws that govern the behavior of all these matters in the universe. So in physics also we need to follow the scientific way of the scientific approach for investigating the phenomena, for trying to understand the phenomena. So this is what we what do you mean by physics. So the most important thing here in physics, as we said, the observation. So you need to observe a particular phenomena. So what we need to do is we need to observe the event. The first thing is to observe the event and identify the physical quantities. So when I said identify the physical quantities, what do you mean by physical quantities? And identify the physical quantities, and then quantitatively quantitative representation, quantitatively um, write the physical quantities, what are they, write the physical quantities, and then you study those. So physical quantities, quantitatively write the physical quantity. So you need to identify the physical quantity and quantitatively write the physical quantity. If you want to write the physical quantities that is involved, those are involved in this in a particular event, what you need to do is you need to first measure them. So we need to measure the physical quantities, and that measurement needs to that measurement needs to be done accurately. How accurate the measurement is and how precise the data is, right? That the measurement, that the raw data, precise the data that is obtained. So it depends on this. So our study, how is reliable or not, that depends purely on the accuracy and the precision of our data, right? Then only we can analyze it in a better way and then evaluate and then give the conclusion about the event or the phenomenon. So here the most important thing is the measurement of the physical quantities. So here we need to understand what is physical quantities, what are the types, and then we need to see what are the ways of measurement and how we can obtain accurate and precise data. And then if there is some error in the measurement, then how we can identify that the sources of error, and how we can minimize or eliminate the errors that or the uncertainties that is present in our data, so that we can give a clear conclusion about the event or the measurement that we did. So this is that's why this is important. The measurement plays an important role in the investigation in scientific approach. Okay, so basically here, when I started with physical quantity, I need to tell you what do you mean by physical quantity. What exactly it means, physical quantity. So physical quantity are those quantities which can be observed, you can observe, okay, it can be observed or it can be measured. That's why, we can also call these physical quantities in alternate words, we can say these are nothing but the observables or measurables, or observables, because we can measure them, we can observe them. So measurables and observables. So there can be many such physical quantities. As we know, I will classify these physical quantities into two different types. So all these quantities which can be observed or measured in the phenomenon in a scientific study or in a scientific investigation are called physical quantities or observables or measurables. So now these physical quantities can be classified into two types. We can divide into two types for the convenience of measurement, so that we can uh, write everything clearly for different types of physical quantities. So physical quantity, basically we can classify into two types. One is fundamental or the base quantities, and the second classification, the second category, we said the derived quantities. So fundamental or base quantities and derived quantities. So, worldwide, by standardizing different physical quantities, we discussed, people discussed, scientists discussed, different countries they discussed, and they, finally we came up with seven fundamental quantities. Okay, so seven base quantities or fundamental quantities, that are those are the minimum quantities which we need to write all other physical quantities, to represent all other physical quantities. So those fundamental, those seven fundamental quantities I said are, I can just write this here. So we have the fundamental or the base quantities, which are the minimum number of or minimum set of quantities that we need to write all other physical quantities. So fundamental or the base quantities. So what are these fundamental or base quantities? So these are the minimum set of quantities we said that is needed to write all other physical quantities. So one is the mass. Mass is one physical quantity which is very fundamental. Then length, time, is also one, right? Then we have temperature, temperature, amount of matter, I will tell you in detail. What is amount of matter? Okay, and then luminosity related to the brightness or intensity of light, luminosity. Okay, and then we have mass, length, time, temperature, amount of matter, luminosity, and then yes, we have current. Okay, so these are the physical quantities. Seven fundamental quantities or base quantities that is needed to write all other physical quantities. Okay, so all these physical quantities need a specific unit to be represented, so that if somebody wants to write the value of mass or length or time, temperature, that unit used or that unit which is associated with physical quantity will give you the value, I mean, how big or how small, and what is the nature of that physical quantity. Okay, it will give you a clear idea of the physical quantity. For example, if you are writing mass is equal to 10, then you may be confused in which, I mean, system of units are you using. Are you writing this as 10 kilogram, or it may be 10 kg, right? So kilogram, gram, or you are writing in terms of pound. So you need to be very clear about the magnitude, the value that you are writing, and the system that is used. So suppose I will write 10 kg, then clearly it is understood. I mean, what is it clearly represents the mass in a particular system of unit. So suppose I will write 10 meter or centimeter or feet, then it clearly represents, these represents the system of unit that is used, and this represents the magnitude. So these things, I mean, that is representing the system, okay, representing of a physical quantities, giving the observer the clear idea. The nature of the physical quantities are known as units. Okay, that's why we need units. Okay, so units are associated with the physical quantity. It gives the clear nature of the physical quantity and the nature of the system of unit that is used to represent the physical quantities. Okay, so for every fundamental quantities, we are going to write the unit that is used to represent them. So normally we will refer to SI, so that is International System of Units. So this is the standardized units that we use worldwide. So just to standardize, my 1 meter should not be different from your 1 meter in some other country. My 1 kg should not differ from your 1 kg. Then there will be a deviation and there will be no common understanding of the units. So it will be a problem. That's why, we need to standardize it, and worldwide we follow one system which is well standardized and well organized as well. So every year there is a conference, in that they discuss about all these standardization processes and all. So system internationally, or we said international system for units. Okay, so this is formed to standardize these fundamental quantities, and accordingly all other quantities can be represented. So for mass, we write it, mass is in kilogram, mass in kilogram. In short, can be written as kg. For length, we write meter, only small m. Time, we write second, so only s. Temperature, we measure in Kelvin. There are other units as well, like degree Celsius, Fahrenheit, and all. But here we are taking Kelvin as the temperature. Kelvin. So small k when you are writing the full name of the scientist, and capital K if you are writing the short abbreviation. Amount of matter, this is written as mole. Amount of matter is mole. So in short, you can write luminosity is candela. Candela, candela. In short, you can write CD, candela. Current is actually ampere. Again, before the name of a scientist. So ampere, and you can write capital A in short. Okay, so these are the units that is used to represent these physical quantities. Okay. Okay, so once you are aware of the base quantities and fundamental quantities, the rest of the physical quantities can be derived. Rest of the physical quantities can be derived using these base quantities. The rest of the physical quantities can be derived from the base quantities. From the base quantities. Okay, and all these quantities we will call as derived quantities, and accordingly we can write their unit. Let us try with some of the derived quantities, simple derived quantities. Let us first go for suppose density of material. Density is equal to, we know this is the ratio of mass and volume of the substance, volume of the material, mass divided by volume. So mass we will write as kilogram in kg, and volume is in meter cube. So density can be written as kg meter cube minus 3. So that will be the unit for density. So now this density requires two fundamental unit quantities to be represented. One is mass and the other is length. So mass and then length to the power minus 3. So one is mass and the other is length. So two physical quantities are needed to write density. That's why we will say this is a derived physical quantity. So this is a derived physical quantity. Okay. So similarly, second, if I'll go for speed, we said this is distance traveled divided by total time. So total distance traveled divided by total time taken. So I will write this is length. So length divided by time. So you got length written in terms of meter, and then you have time, you got second. So we wrote it as ms to the power minus 1. So two fundamental quantities are needed to write speed. One is the length, the other is the time. So this is also a derived quantity. So this we can say this is a derived quantity. Anything other than this, for example, if you write acceleration, suppose we will write acceleration. Acceleration is defined as the rate of change of speed or rate of change of velocity. So if you write this as velocity or speed divided by time. Okay, velocity is a vector quantity, speed is a scalar quantity, acceleration is a vector quantity. So it's better to say acceleration is velocity upon time. So if I'll write here, I mean, only here our objective is to see how many dependent fundamental quantities are here. So if I'll write velocity, we can write this is velocity is equal to displacement upon time. So I can write this is displacement divided by time. That's my velocity whole divided by time. So we got this is displacement one physical fundamental quantity, displacement, that is length, and then time to the power minus 2. So we got this is meter and this is second minus 2. So two fundamental quantities, length and time. So this is also a derived quantity. If you want to write what is force, so suppose I will write force. Force is known as mass into acceleration. Mass into acceleration. Mass into acceleration, we can write, just now we wrote kg, and this one we got ms minus 2. So there are three fundamental quantities. One is mass, the other is length, and the third one is time. So three fundamental quantities are required, or base quantities are required to write force. So we can write, we can say force is also a derived quantity. Force is also a derived quantity. So similarly, I can write this is momentum. Suppose momentum is a physical quantity, can be written as mass into velocity. That's called momentum. We can write this kg, and velocity, as we have already written, this is meter per second. So kg, meter per second. Again, you can say three fundamental quantities are needed. Kilogram for mass, meter for length, and second for time. So we have three fundamental quantities to represent momentum. Similarly, we can go for more. For example, we will write what is work. Okay, work, if you can write, work is force into displacement. So force into displacement, force into displacement. Just now we wrote force is nothing but meter. Okay, kg, meter per second square. So force is mass into acceleration multiplied with displacement something. So I will write this as kg, meter per second square, into displacement is meter. So we got this as kg, meter square minus 2. Okay. Okay, I forgot to tell you that force which we wrote as kg, meter per second square, or we said this is Newton. So for some fundamental, for some derived quantities, there are dedicated units. Like for force, we have one. You can, in SI, actually you can write kg, meter per second square, or you can write Newton. In short, you need to write capital N when you are writing the name of the scientist. You need to start with a lowercase n, and if you are writing in short, then you need to write the uppercase n. So that's where. Or here also you can write this, the unit SI unit, either this way, kg, meter square per second square, but there is a dedicated unit available for work, and which is known as joule. So JLE, or sorry, you need to write this, you are writing the full name of the scientist, joule, or you can write this as capital J, uppercase J. So that is the unit used for work, and work requires three base quantities. That's why it is also a derived quantity. Okay. Now, after this, we can have more. For example, if you are saying potential energy, suppose somebody will say potential energy as a physical quantity, potential energy. The formula is actually mgh, potential energy, kinetic energy, any energy and work, they will have same, they are dimensionally the same thing. Okay, change in potential energy gives you the work done, change in kinetic energy gives you the work done. So energy, work done, potential energy, kinetic energy, they will all be dimensionally the same thing. So here when I'm writing m, this m is actually for mass, g is acceleration due to gravity. So we'll have the dimension of acceleration due to gravity, h is the height, so it will have the dimension of length. So if I'll write it, this gives me kg, that is for mass. And for g, we got ms minus 2 because this is known as acceleration due to gravity. So we'll have the dimension of acceleration, and height, which is the dimension of length. So we'll have meter. So now we can write kg, and we got meter square and s minus 2. So it's a dimensionally, if you see, is the dimensionally same as that of work. or you can write this as sorry, joule or J. Okay, this is same way if you write the formula for kinetic energy of an object. Kinetic energy is the energy produced by the object, by the body, by virtue of its motion. So it gives you half mv square. M is the mass, v is the velocity. So we have the units. We can write that. Half is not considered having any unit, is a numeric figure. So we can just write mass is kg and velocity square, that is ms minus 1 mass per, I mean, sorry, meter per second. So this and then squared. So we got kg meter square and s minus 2. Again, the same dimension, if you'll see, same dimension as that of work. So we can write in SI unit, we can write this as joule or this is the dedicated unit given for work or kinetic energy or potential energy. So this way you can write, yeah, the unit for work, potential energy, and kinetic energy, they are the same, right? Similarly, we can write power. Power is the ability of work done, or we said the work divided by time, or you can write energy upon time. So this gives you work. We got kg meter square and s minus 2 divided by second, you got s. So we can write this as kg meter square and then s minus 2 and minus 1, that gives you s minus 3. Okay, there is a dedicated unit for power which is normally written as watt, or in short you can write w. Okay, so what for power? So that's the SI unit for power. Okay, there are many such physical quantities that we will come across during the course, and we will be deriving all those. So I did few over here. Okay, and okay, something related to the charge. Let's do something related to charge. So if I will write charge, charge is actually a derived quantity because the fundamental quantity we considered is current. So normally if I write charge, charge is given as current multiplied with time, current into time. So for current, the unit we said ampere, and the time we said this ampere second. There is a dedicated unit for this ampere second. We call the unit for the charge is coulomb, 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 or in you can write this when you are writing in short. Okay, so charge is one. Suppose okay, let me write what is electric field. Few more derived physical quantities we can discuss. Let's consider electric field. Electric field is one which is defined as actually the electric field force, the field force, electric field force, electric field force per unit charge, per unit charge. So force, we can write anything in the form of force can be written as Newton. So I can write this as Newton divided by charge. Just now we said ampere second or coulomb. Okay, so we said this is coulomb. We can write Newton per coulomb. So we got Newton and coulomb inverse. So this way you can write with unit charge. Okay, if you want to write in the using the fundamental quantities, then also you can write. So force can also be written as kg meter per second square, and charge can be written as ampere and second. So we can also write this Newton per coulomb, or you can write this kg meter ampere inverse, and then you got s minus 3. This also represents the same. So Newton per coulomb also can be written as this way. Okay, so this is the easy way of writing the unit. So unnecessarily do not make it complicated like kg meter ampere inverse s minus 3. You can simply write Newton per coulomb. But if you want to see how electric field is, is a combination of more than one fundamental or base quantities, that then you can see from this kg for mass, meter for length, ampere for current and time. So more than three, you can see 1, 2, 3, 4, 4 base quantities are needed to write what is electric field. Okay, same way you can write it for magnetic field. Magnetic field also can be written that way, the magnetic field. So there are formulas for magnetic field. One formula is the Lorentz force. We call it Lorentz force. So force can also be written as QVB. I'm just writing to understand it dimensionally. So F is equal to QVB. F is the force, Q is the charge, V is the velocity, and B is the magnetic field here. F force, Q charge, V velocity, and B magnetic field. So we can write B is equal to F divided by QV. So you can write that way V. So you got Newton, and then you got Coulomb, and you got velocity is meter per second. So this is meter per second, ms minus 1. So this gives us Newton, Coulomb inverse, meter inverse, and then second. So that way also you can write what is the magnetic field, I mean dimensionally. Okay, so these are a few examples of the physical quantities, derived physical quantities I showed you. In the course, we will come across with many such physical quantities, and we will discuss those that time. Thank you. We will continue the other things in the next video.